Welcome back to part 2 of Module 9, Lesson 5, where we continue our study in surface area. We're looking at example number 2 now, where they want to know how much paper is going to be needed to cover the gift box that is shown, and it is a triangular gift box. Now yes, you and I both know that when you wrap presents, there's always overlap. They're not counting overlap, they're counting the exact amount of paper that would be needed if you were able to get all the seams perfectly. That's going to be the surface area of this box. Now because this is a triangular prism, we're going to, of course, it doesn't matter what type of prism it is, we're still going to need to take and make a net of it. That's our first step in finding our surface areas. So let's find some clean real estate here, copy it in and paste, and here we go. I'm going to start off by taking that long rectangular base that she's sitting on. So that means I'm going to have something that looks kind of like this, and that is going to be this distance right here is going to match up to stand by. I do believe they're claiming that's an equilateral triangle, but let's look at the instructions, see if the instructions match up to that. So stand by just a second. Alright, I don't know why I wasn't seeing that, but it says right there it's going to be 4 inches. So we're going to take this 4 right here, and I'm going to put it right there, and we're going to take on either side of that, and I'm going to put these two, and it's not as clear, but this side is congruent to that side. So I'm going to have 2 rectangles here on either side of that one that are congruent as well. And they're going to have bases of 3.6, and the height of everything, that's going to be this distance right here, that's going to become 14. Now I also need to put my triangles in, and my triangle end pieces are going to have heights on them of, it says 3 inches, so I can put a 3 there, and we're going to take and use that as our starting point for solving our problem. Next, I'm going to start finding the area of my pieces parts. So I'm going to go back to that blue rectangle, and the area of a rectangle is going to be length times width. So my area is going to equal to, the length is going to be 4, and the width is going to be 14. 4 times 14. So area is going to equal to 40 plus 16 is going to be 56. And I'm going to write that 56 right here. Go ahead and box that off. Keep our work neat and organized. My red rectangles, area is equal to length times width. Area is going to be equal to, here I have a length of 3.6 times a width of 14, which is going to end up being, let's just go ahead and use a calculator to make sure we're getting this all right. I'm going to have 3.6 times 14 equals 50.4, 50.4. I'm going to write that in here, and I'm going to write that in here. Now I need to box that off and find the area of my triangles, and triangles are of course going to be base times height divided by 2. So I'm going to have a base of 4 times a height of 3, because you have 4 and 3 right here. So times the height of 3, all divided by 2. I'm going to simplify. 2 goes into 2 once, 2 goes into 4 2 times, and multiply, which is going to give me 6 over 1, otherwise known as 6. And I can put that 6 here and here. Now all that's left to do is add it up. So I'm going to put my 2 6s for my triangles, my 1 56 for my bigger rectangle, and my 2 50.4s for my little rectangles. Add those up, annex in some zeros. That's going to give us an 8. That's going to give us an 18. Bring down the decimal, and that's going to give us a 16. Our final answer, 168.8. Alright, now let's take and compare the answer I got to the answer that the textbook's going to give us. So I got 168 and 8/10. So I'm going to jump over here. I don't really care for how they show their work on this, because they don't. They just boom, 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 and all of a sudden they have their answers. 168.8. Check the answer, and the answer checks. This right here, folks, that's going to be showing your work. That's what I've got to see on this problem and each and every problem like it. Now it's going to be your turn once again. Let me reset this one. And you guys are going to work on extra example 2 on your own. Make a net. Have good supporting work for your net. Show how you found the area of each piece of the net. Add them up and see if you can find the right answer. Go. Alright, first thing I'm going to do to make my net is I'm going to draw the rectangle that it's sitting on. So, whoops, let me get my pen going here again. And we're going to make that a black rectangle as our starting point, because every shape's different here. So I have a black rectangle it's sitting on, and it's going to have an 11 1/4 and a 6 3/4. Next, I'm going to draw that big honking rectangle. I'm going to make that one blue, and that one has the same width, but the length of it, you can see right there, is going to be 12 3/4. And then I'm going to do my short rectangle that's up against that dirt berm. Has the same length of 6 3/4, but this one has a height of 6 right here. Now comes the really tricky part, which is going to be to line up our triangles in such a way that they're going to fold back up and properly to make our box. So in doing that, I'm going to set it up to where my triangles are going to have a short end, which matches this side, the long end matches the long side, and the middle length end matches that. Same thing here. Short, middle, and long. So now I've got my triangle there, and my triangle, of course, does meet at a right angle, so the dimensions on that is going to be the 6 that we have here, that matches there, and over here, the height of that triangle, we're going to call 11 1/4, which matches this side right here that you see in your image. Now I've got everything I need to start doing a lot of grunt work to find out the area, surface area of this polygon or polyhedron. So the first rectangle is going to be length times width, which means I'm going to have 6 3/4 times a width of 11 1/4. Change those to improper fractions. 4 times 6 is 24, plus 3 is going to be 27/4, times 4 times 11 is 44, plus 1 is going to be 45/4. Unfortunately, nothing is going to simplify in that problem, so I'm going to take and grab up my calculator here, and I'm going to say 27 times 45 is going to equal to 1,215 over 4 times 4 is going to be 16. I'm going to write that in to that rectangle right there. Now I do want to take a minute and go back and circle that answer. It's not the final answer, but it is an important sub-answer here. And I'm going to draw a line so I can keep my work neat and organized. And now we're going to go for my blue rectangle, which is going to be the same formula. And this time I have a base of 12 3/4 and a height, or I guess we call those length and widths, of 6 3/4. That means the area is going to equal to 4 times 12 is 48, plus 3 is going to be 51/4 times, and the other is going to be a 27/4. Once again, nothing is going to simplify in this, so I'm going to grab my calculator. I'm going to do 51 times 27, and that's going to equal to 1,377 over 16. And we're going to put that in the middle of the blue, 1,377 divided by 16. And I'll put another line here and circle that, keeping my work neat and organized. Now it's time for my green rectangle, which is still area is equal to length times width. Here we have a little easier math to go because my length I have down is 6, and my width is still going to be the same, 6 3/4. That means it's going to equal to 6/1 times, and the 7/4. This will simplify a little. 2 goes into 4 twice. 2 goes into 6 3 times. And now I can multiply that out in my head. 3 times 27, that's 60, plus 21 is going to become 81/2, which I'm going to take and write right here. Circle that answer, draw my line, and now it's time to do the triangles. The triangle formula is area is equal to, since we're dealing with fractions, I'm going to use a fraction formula, 1/2 times base times height. For this one, my base and height always meet at right angles, so I'm going to have 1/2 times, I'll use the 6 as being my base, so I'm going to call that 6 over 1, times my height is going to be the 11 1/4. Alright, so that means I have the area is equal to 1/2 times 6 over 1 times 4 times 11 is 44, plus 1 is 45 over 4. I'm going to go ahead and do a little simplifying. 2 goes into 2 once, 2 goes into 6 3 times. And then I'm going to multiply. 1 times 3 is 3, 3 times 45, that's going to become 120 plus 15, so it's going to be 135 over 1 times 1 times 4 is 4. And I'm going to put those 135 over 4, 135 over 4 in my red circles. And the red triangle, excuse me, we're going to circle that. Now it's time to add them up, and that's going to be a little bit of a challenge. What are we going to do? Well, we're going to start off with our 1215 over 16 plus my blue. I had one blue at 1377 over 16 plus I had one green, which was 81 over 2, and then plus I had 2 of my red triangles, 135 over 4 plus 135 over 4. My least common denominator in all of that is going to be 16, which means that one gets to stay the same, and it means that this one gets to stay the same. Now things get a little ugly. So I've got to get a 16 there, and I'm going to have 16s here as well. For my green rectangle, 2 goes into 16 8 times, and 8 times 81, we're just going to go ahead and do that here. 81 times 8 is going to equal to 648, and then here 4 goes into 16 4 times, and 4 times 135, that's going to end up being 540. Whoops, that should be in red, so I'm going to change that back to red. 540 and 540. Now we're going to take and add up all those numerators. Let's clear everything out. I have 11215 plus 1377 plus 648 plus 540 plus 540, which is going to equal to 4,320. So go ahead and throw that down as 4,320 over 16, which is an improper fraction. Maybe we'll get lucky. Let's try dividing it by 16 and see what happens. It does work out beautifully. The surface area of that entire triangular prism is going to be 270 square, whatever the units were, square feet. Jump back over to our textbook, which is right here. Plug in our 270, check the answer, and after all of that really ugly work, the answer actually worked out in our favor. That's going to be it for part 2. Come back for part 3. This is a long lesson because of all the intense supporting work we're having to show. And in part 3, we're going to start working on the surface area of pyramids.